Welcome back. Today we are going to be working some more with word problems and also some calculation practice, more with equations. And we're going to start off by talking about a ridiculously long fruit roll-up. So if you would get your journals open to page 202, we will get started. Come on around, cameraman. So, a 6-foot piece of fruit snack? What? 6 feet? Is cut into 2 pieces. What is the length of the shorter piece of the fruit snack? For goodness sakes. Okay, so look at this thing. So one length of it is 3 3/4 feet. And what it's asking is, how long is this one? So they have done it a couple of different ways. Here is a bar diagram, and you can see the whole thing together equals 6 feet. A longer piece equals 3 3/4 foot. And then there's this shorter piece here. So this is what we're looking for. And they used an addition problem here. They said 3 3/4 plus x equals 6. And then you just solve for x. So if 3 3/4 plus 6x equals 6, then you would subtract 3 3/4 from both sides of the equation using the inverse relationships and properties of equality. And then you would get x equals 5 4/4 minus 3 3/4. Now, why did they make that 5 4/4? They did it so you would be able to subtract. If it's just a whole number, you can't subtract that fraction. And then you end up with 2 1/4 foot of fruit roll-up, which is a ridiculously large fruit roll-up. Okay, now try it. Suppose you cut the shorter piece of fruit snack from the example above into 2 pieces. So you have that 2 1/4 foot long piece, and you cut that into 2 pieces. And we know that the longer of the 2 pieces is 1 3/8 feet long. Okay. And then complete the bar diagram to represent the equation, then find the length of the shorter piece. So we know that this whole thing is 2 1/4. So you'd write that there. This is the shorter piece we don't know, but it tells us that the longer piece is 1 3/8. So you can write that there. Now take this bar diagram and turn it into an equation. Here's what they did. 1 3/8 plus x, that's that shorter piece that we don't know about, added together, that equals 2 1/4 feet. The whole thing is 2 1/4 feet. So 1 3/8 plus x, and then it says minus. Well, we're trying to get x all by itself, right? So it's minus 1 3/8. And then the other side of the equation, 2 1/4. We subtracted 1 3/8 from this side, so we have to do it from this side too. So again, minus 1 3/8. Then you get x equals 1 10/8 minus 7/8. And why is that? They changed 2 1/4 into 1 10/8. And then they were able to subtract the 3/8, 1 3/8, excuse me. That should go there. And the solution to that is 7/8. So the shorter piece of the fruit snack is only 7/8 of a foot long. Plenty of fruit roll-up, if you ask me. Okay, convince me. How does the equation change if you know the length of the shorter piece is 7/8 of a foot and you wanted the length of the longer of the 2 pieces? How would that equation change? Let's look at it. So now you no longer know this, but you know that the shorter piece is 7/8. So you would just swap that out, right? So you'd have 7/8 plus x equals 2 1/4, because it's the same kind of equation. You just have a different piece of information that you're looking for. Okay, let's look at 203. Use inverse relationships to solve each equation. Remember, inverse relationships, if you're adding, you need to subtract. If you're multiplying, you need to divide, and so on, right? So, y minus 4/9 equals 5 1/3. What are you going to do to solve that? The variable is minus 4/9, so you need to add 4/9 to both sides, and then you'll get 5 7/9 for your answer. This one, 3/8 n equals 3/4. So we know this means 3/8 times n equals 3/4. We want to know what just n equals, so we're going to divide this by 3/8, or look what they did here. Instead of dividing, they multiplied by the reciprocal of the fraction, which turns out is the same thing as dividing by the original fraction. Do you see this is 3/8? This is 8/3. So if you want to divide, you can also multiply by the reciprocal or the flipped fraction. Okay? Now let's take a look at C. P over 5 equals 8. Okay? Look what they did. P over 5, that means P divided by 5. So they multiplied it by the reciprocal. Instead of 1/5, it's 5 ones, or 5, right? And they get P equals 5 times 8. That's that 5 ones, that's 5. So P equals 40. Try it. Solve 5/9 y equals 25. Solve that for y. Well, it's 5/9 times y. So what I could say is 5/9 y divided by 5/9 equals 25 divided by 5/9. But what I just learned is that I could also, instead of dividing by the same fraction, I can multiply by its reciprocal. So I can say 9/5 times 5/9 y equals 25 times 9/5. And that will cancel these two out, and you will get y equals 45 over 1, which is the same as just 45. Okay? All right, so multiplying by the reciprocal of a fraction is the same as dividing by the original fraction. All right, let's talk about oranges. Molly bought these oranges for $7.15. She paid the same amount for each orange. Write and solve an equation to find M, the cost of each orange. Draw a bar diagram to represent the situation. I'm just going to point out here that they definitely said she paid the same amount for each orange. What if we didn't know that? We wouldn't be able to set up an equation, right? So that's something that you need when you're solving equations. You've got to have this sort of constant value. Okay, so let's look at this bar graph. Total cost is $7.15. And then each of these M's is the cost of an orange. Okay? So 13M, because there are 13 oranges, equals $7.15. So it's 13 times the cost of each orange, each equals the total cost of all the oranges. So we divided both sides by 13 and found out that each orange costs 55 cents. All right, you know how to divide with decimals. Remind yourself if you need to. Let's do it with the try it one. So Molly also buys a bag of 8 apples for $3.60. Write and solve an equation to find out how much Molly paid for each apple. So here's what I did. I said 8A because there's 8 apples, and I don't know how much each one is. So A is going to be the variable I use for the cost of each apple. So 8 times the cost of each apple equals $3.60. I'm going to divide both sides by 8, and I get A equals 45 cents. Well, let's just take a look at dividing decimals in case you need a little refresher. I've got $3.60, and I'm dividing that by 8. So I've got a whole number here, so it's pretty straightforward. All I have to do here is make sure that I bring that decimal straight up here into my answer. And then I'm just going to divide as usual. I can't divide 8 into 3, so I'm going to go over to 36 and say, well, 4 times 8 is 32. And there's 4 left over. Then I'm going to bring that 0 down and say, how many times does 8 go into 40? 5 times. And it works out evenly. Okay? All right. Let's take a look at page 204. All right. So again, it's reminding you about the inverse relationships and using those to solve equations, right? This is m plus $5.43. So what are you going to do to get m all by itself? You're going to subtract $5.43 from both sides. Same thing here. This is y minus 6.2. Well, you've got to add 6.2 to both sides then, and you end up with y equals 9.1. And here, it's x divided by 2.5. That means you've got to multiply both sides by 2.5. Okay? Now let's try it. Carmen spent $12.50 for a new notebook and a compass. The notebook costs $6.35. Write and solve an equation to find C, which is standing in for the cost of the compass. Okay, so we know that she spent $12.50 total. And we know that the notebook was $6.50. What we don't know is the cost of the compass, and we're using C to represent that. So there you go. The cost of the compass plus $6.35 equals $12.50, which is the cost for both of them. So you're going to subtract $6.35 from both sides, and then you will get $6.15. Okay, this is more, the rest of this page is just reminding you of how to do things using that inverse relationships and properties of equality. So this is a good page to go back to if you kind of forget how to do that. Go back and take a look. Here's an addition equation and a subtraction one, a multiplication and division. It breaks it down in a bar graph for each of them and then creates an equation and then solves it and tells you exactly what to do. So if you get confused, go back to page 204 and you've got awesome examples of all 4 of those. Okay? Now let's look at page 205, which I think is our last page for the day. And we've got a few do you understand problems and then just some practice solving some equations. All right. How can you write and solve equations involving rational numbers? Remember not to overthink this. What do you do when you write and solve an equation? What are the steps that you need to do? Construct arguments. Why are inverse relationships important for solving equations? Why do you need that, right? Critique reasoning. Johnny says that he solved the equation x minus 3.5 equals 7.2 by adding 3.5 to the left side of the equation. Is Johnny correct? Explain. Generalize. When solving an equation involving a mixed number, such as y plus 3/4 equals 4.5, what do you need to do with the mixed number? We did some problems like those earlier today. What did we have to do with that mixed number? Okay, construct arguments. How is solving an equation with fractions like solving an equation with whole numbers? How is it different? Remember when we had that question about how is solving with money different from solving with whole numbers? It's the same kind of thing. And then for the whole right side of the page, it's just solving these equations. They're all set up for you. You just have to solve them. So why don't you pause the video here, and then when you're done, you can unpause it, and we'll go over the answers. Okay. That's a strange answer. How can you write and solve equations involving rational numbers? Enough already. We've talked about this 8 million times. Okay, you need to get a variable, right, for the missing amount. And then you use properties of equality, you use the inverse, and you solve them. Okay. Construct arguments. You use them to get the variable alone on one side, which is critical. That's what you do with those inverse relationships. It's the whole kind of the heart of solving these equations. For this one, I said, Johnny, for goodness sake, pay attention. We have to do the same thing on both sides of the equation. I don't know what's up with Johnny. I mean, I think we've talked about this a lot, right, Johnny? Okay. When solving an equation involving a mixed number, such as y plus 3/4 equals 4.5, you have to rename that mixed number as a fraction. So for 4.5, you'd have to change it to 9/2 and then convert that into fourths. Okay, because otherwise you're not going to be able to subtract. All right. And then with this, it's the same. You just need to convert. You may need to convert some fractions, but the strategies are all the same. Okay, let's see how you did with your calculations. Number 6 is 26 5/12. Number 7 is 1 1/4. Number 8 is 37 72/100. Number 9 is 100 1/10. Number 10 is 1 3/10. Number 11 is 22 3/10. Number 12 is 5 2/100. Number 13 is 24. And number 14 is 11/12. Okay. That is it for today. I hope everything is going well, and I look forward to seeing you in our next small group meeting. Feel free to email me questions or put questions in the comments below. Thanks, you guys. Bye.